the hardware, the software, and 3D printing as well. And I'll show you some of my experience with crowdsourced funding, as I ran a Kickstarter campaign to attempt to try to fund this. But I learned a lot all along the way, and I'm really happy to be able to share some of that with you. So first of all, with FunCase, you know, a lot of my work during the 20-teens, I spent quite a bit of time in kind of the intersection of technology and how it would work with kids and education and smart toys, smart spaces for kids. Then I kind of came out of that work. I'm in a different area now. I'm working on developer experience. So I've kind of gone to the other extreme of adult developers and how they work with the tools that Intel provides. And this is still some area I'm interested in with kids and programming and how they learn to code. But, you know, I borrow a lot from a lot of these concepts that have come up around multimodality learning, all the way back to Piaget and the developmental psychology for children and how building helps kids in learning. And that's been a big influence on Montessori schools, and a lot of research has been done in the decades about that. So I'm really leaning on a lot of that background. The other area that I want to point to is MIT Scratch. Mitch Resnick and people he works with at MIT Lab, I think almost 2 decades ago, started working on Scratch. And it's a platform to allow kids to learn how to code in a very simple way. And you'll see as I go along, and pretty much there's been publicly available libraries that allow people to build their own applications based on those concepts. And so you'll see a lot of that as I go along. So I'll give a coverage of KidSpace and what it is, and then I'll pause for some questions here. There's a few places in the presentation I'll sort of pause and we can talk about any questions you have as we go along. So there's 3 main components to FunCase. So the first is a Blockly interface inspired by MIT Scratch. I believe MIT and Google work together on Blockly, and now Google supplies that library publicly as open source software that anyone can use in their applications. And it's this, you know, simple application interface you see where you can essentially drag and drop your command statements. You can see here there's a little repeat loop. And you can imagine with conditional statements, you can go from very basic sequential commands to nested loops and things that more advanced usage can enable. The second component of FunCase is a really simple robot that you put the phone on and the robot will drive around and follow the instructions that you programmed on the interface. So if you told it to, if you put a turn left inside of a loop and you repeated that loop 4 times, your robot will go and it'll turn and it'll turn and turn and perhaps come back to you depending on the turning angle. Then the third space, the third area is the animations, the characters that are presented on the phone screen as it moves around. So it's sort of, I look at it as sort of a reward or an entertainment aspect of the experience where kids can kind of get a kick out of seeing how these characters react as they ride around on the robot. So one of the things that I arrived at with FunCase, I was trying to think of a low-cost approach to smart toys. I think there's a lot of $100 plus products on the market, and I think, you know, sometimes those, you know, some of those are fairly popular. I wanted to come in with a lower cost approach for, I guess one is just practicality of products, have something in that kind of $30-ish space where someone doesn't have to make as big of a decision, as big of a commitment to buy something. I think the other area is, you know, I think built into that, there's a little irony that, hey, here's this cheap smart toy. All you need is a $400 phone to put on it. So I'm not, that doesn't escape me, but I'm thinking for like volunteer efforts, you could get people to donate their old phones and you could have, 10 phones and 10 cases and handle a small after school group, for example. And actually, toward the end, I'll talk a little more, but that's more about where my thinking on the project is at the moment, is kind of building out some of these prototypes to actually do that sort of volunteer work. But I think the other probably challenging part of a product like this is like the prototype that you saw on the first, on the cover page. It doesn't offer much protection for the phone. So, if a phone goes off the table and breaks, that's no good either. So I think, as the prototyping and iteration goes on around this, think more about how to protect the phone. There's integrated approaches where you might get a screen and put it in there and it would be a devoted screen to the product. But now you're back up in that $100 plus range where you've got a pretty expensive bill of materials. But yeah, so that's where I've arrived, at the moment with FunCase. Any questions on sort of the concept? I mean, the next sections I'll jump into more of the maker space and what's available there. Any questions about the product concept before I move on?
My question would be, what inspired you?
What's that?
But my question would be, what inspired you to do something in this space specifically?
Yeah, well, I spent a few years on, at Intel. Intel used to have an interest in microcontrollers, like these really tiny little processors that cost less than $1 a piece. And it looked like, and this was all publicly announced, so I'm not telling you any secrets about Intel. But it's a really hard place to take on the competition that's already there and for it to be a profitable market for Intel. So they eventually pulled out of it. But at the time Intel was into it, we had some really interesting potential partnerships with some toy companies, and we explored some really interesting smart toys. And kind of after all that was over, and just a few years ago, I was thinking about coding interfaces and how they could be more approachable and fun, and kind of arrived at this. Yeah, and I see it as something that isn't particularly. I do a fair amount of work in patents at Intel, so working for a large company, you usually can't go off and invent your own things for yourself unless you clear that. So I don't really look at this so much as an invention area; it's more of an application area, taking a lot of these tools and technologies that are available out there in the world and pulling them together for an experience. All right. So I'll go into the electronics part of the makerspace. So I've been spending my time, I started with Arduino, so I'll talk a little about that. And then I moved into these Adafruit boards. These supply some really interesting functionality from Adafruit. First of all, Arduino, I think most of us have probably heard of it, and maybe some of us have even worked with Arduino. So they're probably one of the best known entry points into maker electronics. If you want to do really simple electronics like wearables that light up, or you want to make your own motion sensor that rings an alarm when you detect motion, you can do all sorts of these very sensor output oriented projects in a very easy way with Arduino. And it's a great introduction to ramp up to technology. I think, you probably wouldn't, like with FunCase, I'm thinking more about younger kids being able to approach this, or someone who really isn't interested in this more of advanced use. So this is kind of the next level when you're past maybe doing Scratch and you want to start doing some functionality with hardware. But there's a lot of basic kits out there that you can purchase with Arduino, some sensors to get started. The hardware setup is very simple. You connect it to your computer, that powers the board, and you can start plugging in wires into these little breadboards that you can see in the lower right here. This is a diagram, but the breadboards look very much like this. And you just plug your wires in there, you plug your sensors in there. And you can start doing, very basic prototypes the first evening that, you sit down with this. Up here in the upper right, you can see the programming environment that they supply. And so this code is called processing, and it's a very simple type of code, sort of a very truncated sort of Python type of code. And when you start doing projects with it, you go to websites, you find a project you like, you can just cut and paste their code right into your application. There's a lot of shared code out there for this. Then you can start changing it and getting a feel for what you want to do. And if you have a different sensor, you can plug that in and start working with that. So it's this really nice way to sort of ramp up your experience. There's lots of online, since it's such a well-known platform, there's lots of online resources for learning. And then I found for myself, the learning transferred into more advanced use. I had, before I started working on this and, sort of a hobby, I hadn't had any real strong hardware background in these types of boards. And I found it very easy to approach. But then the learning that I did do on Arduino transferred onto the slightly more advanced platforms I'm using. If you want to stay in the Arduino world, Arduino Nano are these very small boards. I was looking to see if I have something in comparative size, but something the size, of a couple of thumbnails that you can shrink your project down. When you start to go small though like that, you're probably getting into doing some soldering, and things become a little more advanced. And I'll talk a little more about that on the next slide. And Arduino is relatively inexpensive. You can get a full board for less than $20. And I think I'd highly, if you're really entering into this new, you definitely want to get that full-size board because it's much easier to use at first. The boards that I advanced to then are from a company called Adafruit. I'm not affiliated with Adafruit, but I have lots of good things to say about them because it's a really great company that sells these boards at a low cost. They do a lot of the hard work around things like integrating sensors into these boards. They do a good job of documenting it and supplying videos and code samples to get people started. They really recognize that people are, entering into these projects without a lot of experience, and they take that into account. And they've got a programming language they call CircuitPython, and so it's sort of a reduced version of Python that allows you to do some fairly advanced things. You can call in all these extra functions from library, kind of code that you don't even have to write. You bring in these libraries, you can run these, run this code that other people have created without necessarily understanding a whole bunch about it. And if you're like me, I'm usually trying to learn as much as I need to kind of advance to the next step of what I'm working on. But yeah, like Arduino, there's lots of online training and projects. The Trinket M0 is the one I'm working with now. You can see I've labeled one over here on the right in one that I'm working on. And those are only about $9 a piece. But yeah, now it's down small enough where you're probably going to be doing some soldering. And if you're making like a small prototype that you actually want to be able to move around, like a robot or a wearable type of thing, you probably want to be able to do that anyway. Soldering it's a pretty simple skill to acquire. Some people are sloppier at it than others. I'm one of the sloppy people, but I've rarely, I would have thought I would have been burning up components with my soldering, but the components are pretty robust. So I've once in a while I'll damage something badly, but it's surprising how robust components are. Yeah, probably some of the hard things about getting started with these boards is getting the firmware that's installed, getting the firmware installed on them. So there's this really low level hardware that you don't even see as a user, but those basic software components need to be on the board. And sometimes they arrive with it. Sometimes they have an old version you have to update. So it does take a little patience to read through the online approaches to doing this. It's all documented and out there. You just want to leave yourself a little time and patience to get through those things. And the Python library setup's a little tricky at first. When you get the hang of it, it's pretty nice. So you install it on your board, and then depending on what you want to do, you just copy over the extra libraries, the extra pieces of code that enable you to do that. So when you plug in these boards, they appear as a kind of like a USB drive on your computer. And for this part of the process, a lot of it's just dragging those programs over. And then you're ready to kind of show, go what I showed you with Arduino. You have your breadboard and you start to plug in your sensors and you write your code. And there's a lot of great projects out there. For me, I really like being able to copy someone else's project that's been shared and be able to edit that to make changes to it. That, for me, that's a good way to learn versus starting from scratch and going through a 10 or 15 hour tutorial. Some considerations, when you're getting into the space of boards, maker hardware, there's a little bit of a trade-off between integration and flexibility. So I find it helpful to buy a board that already has as much on it as possible that I may need. So a lot of these boards have built-in accelerometers and other kinds of sensors, and it's all kind of packaged and ready to go and very easy to work with. Some people, as they get more advanced, may prefer to buy components individually and have more control. Sometimes you want a sensor somewhere else that's not on the board, and so you buy that sensor separately. But I really like a lot of the integration that's happening. And my latest round of prototyping is with, I don't know how well this will show through, but with another board from Adafruit that has integrated Bluetooth. And yeah, that would be for me, that's much easier than buying a separate Bluetooth chip and getting it working with the M0. So yeah, they've really made that easy to approach. I think you want to think about as you go along, like if you're using Arduino and maybe you're fairly comfortable with it, maybe you want to stay in that environment. But if you find it too constrained, move on to these more advanced environments. For ordering hardware components, just as a practical matter, be a little careful. It is all documented, and if you're careful, you'll get what you're after. But if you're not careful, you can end up with different versions of boards. And so you might wait a week for it to come. It comes to your house. It's the wrong thing. If you send it back, that takes a long time. So just some extra, being careful with that. Also keep an eye. It's kind of a funny thing when you're doing maker stuff and you got something you want to do, try to think ahead and get your ordering done. Otherwise, you kind of hit these pauses where you're waiting for things to arrive. And almost all of it, especially during COVID, is mail order. I'd recommend getting a variety of sensors to work with. You can buy these sensor kits for like the $20 range, $30 range that have a lot of different sensors in them. You can try them out, test different things. And finally, I try to keep a spare of things if you can afford it. It's nice to have a second component for things that you're relying on so that if something isn't working, you can swap in another one of them to see if that works. Or if you definitely short out a product, you see a little smoke coming from it, you can replace that with something that's standing by. Because it can be a little disappointing to kind of hit these points where you really can't do what you want to do because the hardware hasn't arrived to your house. Any question on sort of that hardware ecosystem part of it before I move along into the software?
There is a question from Daniel. He's mentioning where the programming done on Mac. He's asking.
I'm sorry, what was the question?
So he's asking where is the programming done on Mac?
Oh, either the Mac or Windows. So most of, I think like Arduino supports both environments. So it'll launch a little developer environment, which is a little program that runs on your computer, and you can write the code inside of that. I believe Arduino supports those different platforms. When you're doing Circuit Python, you're probably going to use an editor called Mu, M-U, and I know that runs on Windows because I use that. I'm pretty sure it supports Mac. But if it doesn't, it's a pretty simple text, editing interface for programming. And so there are versions of these little editors that are supported on Mac as well. All right. Okay, I'll jump into the software side of it. So some of the primary areas in the software application side of it for me have been, as I touched on before, Google Blockly and JavaScript. And then Unity 3D is another application that I used for the characters that you saw. And then finally, Autodesk has a product called Fusion 360 that I used for building my cases to prepare them for 3D printing. So first of all, Blockly and JavaScript. For my project, I decided on the project first, and then I got pretty lucky. I knew there was a Google library out there already, Google Blockly. I already knew that existed, but there happened to be a Google Blockly sample that worked very nicely for me. So I was able to really take advantage of code that Google had already published and shared as open source. So my recommendation out of that is to, once you decide what you want to do, to take a really good look around for these existing samples and leverage those as much as you can, to the extent that it may even influence what language that you use. I have a little bit of software development background in doing some scripting way back when things like Visual Basic were popular. But it's been a while since I've done much development, and I've been able to learn enough JavaScript and follow it well enough to be able to edit what's been provided, because I needed to do that, application on the smartphone. And running that application in the browser is nice. So, JavaScript, it's kind of meant to develop for web interfaces, and so browser extensions have gotten pretty ambitious so that you can start to do things like access sensors on the device, or in the case that I'm doing now, be able to communicate via Bluetooth to the robot that I'm running. So I've got a Android phone, and then it runs I run the code in the browser. In that context, the software stack for Bluetooth, and then that sends the commands to the robot. So this side of JavaScript and browser-based development I found is very nice for what I have to do. If all of your code is sticking to the maker kind of robot side of it or wearable, a lot of times those are self-contained devices and you won't have this kind of extra challenge around application development, because it is some of the most challenging things, because depending on the complexity of your application, it can get pretty challenging. Yeah, I think, and then lastly, I'd say most of the software is free for individual use. So if you want to try out, these are open source libraries, but all the development environments, everything, until you actually ship a product in, or you're in a large company and you need a license for an individual within that company, most of this is free for individual use. And open source software, of course, is free, for extended use and even distribution. So as long as you're not distributing projects and selling things, you can do a lot in the application development space for free, which is pretty nice, I think. In another area of, like I mentioned, I use Unity 3D for the characters. So Unity is, you know, I think there's easier environments out there, and a friend of mine said you might check out 3ds Max if you need something a little simpler. Unity 3D is used by gamers to develop games, and you have these 3D environments and 3D animations. The cool part of it is you can go pretty far in Unity 3D with having animations interact with kind of little environments that you make for them. And the Unity Asset Store has a lot of animations. So in my case, I was able to purchase these animations for use from a company called Picturefry. And you know, once I distribute, if I were to distribute that as a product, I'd check back with them to see about licensing. But definitely for individual use, a lot of these animations that you buy within the Unity store can be as little as $5, or you know, maybe some. This had like a dozen of these little monsters, and they had all their animations built with them. And so you import those into Unity, you import their animations in, and you can do quite a bit with them. And then, so for my purposes, I'd record them within Unity and save those out as little videos that would play on the phone. So Unity is pretty cool, but it's a little intense. But if you actually get good at Unity, you can make a pretty good living at it. Unity is a very powerful, serious environment. But I would say, you know, again, just individual use is free. You can install it, try it. You can import some animations and try some things out. They have a decent tutorial structure from the company. And so you can find out whether, you know, that feels like something you need. I think the other thing I'd recommend for a tool, when you're getting to a stage like this, if you Google questions like, what's an easy tool for character animation? You'll get into those discussion groups where people are really talking about those questions directly. And then the third major application area that I spent a lot of time on was Autodesk Fusion 360. Again, this is a fairly powerful tool, but Autodesk also has Tinkercad, which is more of a maker-oriented, much simpler version. I think this worked out for me because I needed a fair amount of precision in printing out the cases that I eventually 3D printed for the project. Again, if you're an individual user and you're doing maker work, you can go quite a while on a free version. I think eventually, maybe after the first year, you might have to purchase an actual license, but you get fairly extended use to try out what you need. I guess if you're sensitive to cost and licenses, it's probably good too when you're deciding on a product to learn to look ahead to see what it will cost you, if anything. Because when you get to that point, you're about to spend a fair amount of time investing in how to use a product. And it's always best if you can pick the one that is going to support you as long as possible. And yeah, and once you get into 3D printing, I'll talk a little more about that on the next slide. Are there any questions at this point about some of the software we just talked about? All right, I'll jump into the 3D printing part of it. I have to say I kind of fell in love with 3D printing. A few years ago, you know, I'd see people get involved with 3D printing. They'd print a keychain, and then you'd hear that their printer stopped working. And so I was a little underwhelmed, and I thought, well, I'm in no hurry to get to 3D printing. But actually, you know, the last few years, and a friend of mine too, she's done a fair amount of 3D printing for a while, and she was very helpful in guiding me in some of these decisions. But so I bought this printer, the Ender 3, and it was a very entry-level printer, but I have to say it works really nicely. The 3D printing market's a little funny. It's almost like open source software in a way, because things are put out there in the environment, and there's a lot of companies, some in Taiwan, some in China, that kind of put together these 3D printer packages and ship them. I think the main thing is to, you know, be sure that you're reading the reviews of the specific ones that you're buying, to be sure that other people have ordered this exact same kit and are happy enough with it. But it's not like you buy an HP inkjet printer and you call tech support if you have a problem. It's more like open source software. If you have a problem, you're kind of on your own. I think most of the companies maybe have a return policy, but a lot of times, that's going to be difficult. But there's a lot of online content, a lot of YouTube videos. 3D printing, it's another one of those things that takes a little patience to get involved in. And it's not something you want to try to do in a hurry. There's instructions that come with the printer that help you install it. And then there's 3D videos or YouTube videos that take you through how to get these printers set up. And it's really worthwhile to watch somebody else do it and look at the instructions and the detail that they have before and while you're doing your own. For example, I made a mistake. Over in this picture, you can see my 3D printer at home, my little buddy. There's a little stopper down here that holds this, the part that puts the plastic out, the printer head. It stops it from going too low. Well, I set the stopper too low. So on my very first try, when I was kind of initializing the printer, it kind of goes around and it goes down and prints a little bit. It moves around and prints a little bit. Well, mine went down and started punching little holes in the platform that that you're supposed to keep nice and clean to print on. And I was I was very careful, but I made that little mistake. I kind of wish that the video I had watched had kind of called out that mistake for me. But yeah, so take your time, watch a few videos. I should probably go add a few comments to some of these videos, because sometimes the videos are done by people who are really good at this, and they use terminology like, stop the, some kind of motor from moving and then do this. And it's like, well, where is that motor? How do I stop it? They how videos like that are, they tend to skip over things they're overly familiar with. So again, you want to look for those kind of entry-level videos, and probably the next time I do a setup summary like this, I'll include more links to things like that, because there were some nice videos. You'll find them though on YouTube, because they do tend to be the most popular ones that are in the search results for 3D printing. Also with YouTube videos, a lot of times as I get into a new area, like setting up a 3D printer or using Unity 3D, I'll compare a couple of instructors. They make a lot of them make these series of videos, and I'll compare them and find one that I like the tone and the speed that they do it, and how detailed they are, and how beginner oriented they are. So I'll kind of judge them again before I spend 2 hours looking at all their videos. Try to spend a little time evaluating who I like the best. Let's see. But I do have to say, 3D printing also is a practical matter. You have the freedom to print what you need. So like on my project, I needed very particular cases. I spent some of my time, and I can show you, finding cases like this that I kind of went out in the garage and I was sawing them the long way to try to make them small enough, because I wanted to get nice and flat. Boy, by the time you spend time finding these just the right cases out there and adjusting them for your needs, you really could use that time learning a new skill like 3D printing. And then I need things like specific wheel sizes depending on the latest case. So it really gives you a lot of freedom if you can just go print those things by yourself. And it's a little addictive. I really like starting a print job, being able to, I start in the morning, come in mid-morning, see how it's doing, and it's just cooking away. They're making this object that I designed. It's something about it. It's very tangible and rewarding. Let's see. Before I move into the crowdsourcing stuff, any questions on any of that so far?
There is one question also. Can you hear me?
Yes.
Okay, so they asking, does Intel utilize like the 3D printing?
Intel, in some departments, they'll have a 3D printer for convenience. Like I worked in Intel Labs for several years, and sometimes, especially the group that did prototypes, they might want to print out a very specific case or something. So they had a 3D printer that they used. And then on the team I was on with some designers, we had a 3D printer because of some of the work that we were doing. It's very particular to a group though, and since most of Intel's deliverables are either software or computer chips, probably not as much 3D printing as you'd have from like a company that's shipping more of the final devices or other products. But here and there, there's people doing 3D printing there. Okay. So yeah, this final part of the presentation is about my experience with crowdsourced funding. I'd come into this, I had sabbatical earlier this year, so my goal was sort of time driven, maybe more than the best way I should have done this. But I really wanted to go through this complete process and get the crowdsourced campaign launched by the end of my sabbatical, because it was fairly time consuming. And having a sabbatical during COVID, it is good to have a big hobby that you're working on. So I decided to kind of go with what I had at the moment versus maybe waiting another 6 months or a year until I had something more perfect. And so originally I was thinking I could maybe do a crowdsourced project like this for maybe $100,000 to make 1,000 of these units, for example, or a few hundred of them. I've had some experience in managing projects where we had to do some software development. I had a really good partner, Matt at MSX Consulting, and I've listed him at the end of the presentation. I actually engaged with him to do a pretty serious analysis of what this hardware would cost and what it would cost to partner with the manufacturer and actually get this done. So I think, sometimes we hear about crowdsourcing campaigns that get funded, but because the person who led it underestimated so badly, it's easy to run out of funds if you really don't do the homework. But then, I soon realized that the cost was beyond what was going to be realistic to succeed within a campaign. And then I also made a design decision that also increased the cost quite a bit, in that I decided for the first product I would include Bluetooth. And to have that wireless connection with Bluetooth, that adds to the software complexity. Plus you have extra costs for the parts and the licenses for Bluetooth. But I really thought for reliability, that would be the way to go. I had sort of a mechanism for the phone to talk to the robot with audio or vibration, and then to have the robot sense that and respond to it. But it turned out to be pretty challenging logically to get that signal through the noise in a way that the user wouldn't have to keep resetting and measuring and calibrating. So I decided if this thing was funded, I wanted it to be reliable. And so I made that decision on Bluetooth, and that increased the cost quite a bit. So the grand total that I arrived at was $353,000, which is really on a Kickstarter campaign for something like this. It's sort of a startling amount to ask for, and fairly unrealistic. And I think going into it at the start of the campaign, I realized that this probably was not a realistic amount. But just in case, I wanted to make sure I did everything I needed to to complete the project, if it did catch on and were funded, which in turn, really helped me learn a lot about doing a project like this. So you can kind of see the breakdown here. Research and development pretty much includes the software development, the whole Bluetooth software part of it, the electronic design, the mechanical design. And so all of that, if you're paying, and for this case, I was fairly, kind of a lone developer on this. So everything else I was outsourcing. So paying the going rate essentially for this kind of development. We arrived at 166, and that includes the application software as well. There's another company that I talked to about software development and got some pretty realistic pricing from them. And then manufacturing is actually, if a manufacturer, buys all the parts and manufactures it in their factory at probably a minimum amount of units, that makes sense for them. We arrived at that figure. And then, so, I assume Kickstarter got, 1 or 2%. They get maybe a little more than that. I think it's more like 5% or 7%. Kickstarter provides a pretty good business, and I don't think they're in it for the money. So I don't begrudge anything that Kickstarter needs to stay on their feet. But then there's also a processing fee. So Kickstarter doesn't handle the financial part of it themselves. So the money comes into this account, it's held there. If you meet your funding goal, you get all of that money at once. And then then the people who committed to the campaign are charged at that point. And so there's another company that takes care of all those transactions. And so they get another amount. And here you can see it came to 17.6. So it's as a percentage of your total cost. Then there's the taxes part of it. So Oregon doesn't have sales tax, but if this product actually, if this project came to fruition and like someone said, all right, Glenn, here's $350,000, go build this, that would arrive in my bank during a tax year. And that amount of money does impact my income a little bit. So there's the potential that you're paying in a higher tax bracket. So you have to be a little careful that you're not inhibiting yourself financially, or you end up having to take a big chunk of your campaign money to pay taxes that you didn't plan on. So I did some reading up on it too to understand, like if I spend all $350,000 on the product, I do not have to pay tax on that. If I pay myself, I would have to pay tax on that. With this project, I was not planning to pay myself. I was looking more toward the future of being able to do products. And there's a margin of error of about 5%. And then fulfillment is all about shipping and packaging. And so you can ship something like this for about $8 a piece within the US, and then probably spend $2, maybe $1.50 on packaging. And then Kickstarter, rightly so, pushes you toward kind of recyclable packaging and limited packaging. So my approach was going to build a very robust product that could ship with pretty light packaging, so that I could keep those materials and garbage down. But anyway, that kind of, they take you through all these steps when you're doing the campaign, and it's another, service that Kickstarter provides. They, kind of guide you through this process and doing your estimates. In the case of the research and development, I needed to rely on some professionals to get at those costs, so I wasn't just kind of shooting from the hip. Yeah. Are there any questions? And I'll talk a little more about the campaign too and how it transpired. But yeah, like I said in the abstract for the talk, my financial success was wildly unsuccessful. I did not even get 1% of the funding. I think there are a few problems with the campaign, I think at its core. One is, like I said at the beginning, I was trying to make an off-the-shelf kind of product that would be more in the range of, well, originally I was thinking $20, and then more realistically, it'd probably be $30 when you think about costs and shipping and being able to make enough off of it that you can invest in other products. But I needed to charge like $99 for a unit in order to fund all that development work. So I think for a crowdsourcing story, you either need a really good story about why you need to overcharge, perhaps to enable something, special, or perhaps in the future, if I do a smaller campaign and my goal is really just to build, 50 units so I can volunteer to help kids in schools. I think something like that is a crowdsourcing thing that's a lot more achievable. The way I did this request for this project, I went out and really just, what if I really wanted to make a product that I wanted to be able to sell and ship? But that's you end up in this kind of high cost range for something that people are looking at as something they're not really ready to spend. I think, then the concept's not perfect either. I think people would naturally have some concerns about the phone getting broken. I think people could be concerned about it being a little noisy. Do I want my kid playing with something like that's going to make noise while it plays? So I think there's a lot of nuance to be done in a product like this. But a couple of really interesting things that I learned in the campaign. One thing you get to do, you probably can't read this text down here, but each of the I did a little bit of online advertising to drive some of the traffic to come and look at the site. Facebook in particular, you can, like $50 at a time, you can actually drive some people to come and look at your site based on Facebook ads. Google is a little more, it kind of ramps up. It starts out kind of expensive per visit, and then as they optimize their algorithms, the cost comes down. It's really fascinating to see how these large companies that do online ads optimize ads for you and drive traffic. It's, I guess in a way it's a little creepy that, big companies can aim ads at you that are so specific. But then on the other hand, you can also see, no wonder these companies are so financially successful. They're providing a service that is really hard to get any other way. But anyway, I was able to track, if I spent some money on advertising on Facebook, I could track how many hits came from that. I could track how many came from Google. I put it out on LinkedIn. I could track how many people came from LinkedIn and looked at it. So with with limited background in this, you can set these things up. And I'd say it's highly educational, if you're going to do things like this. Like the next time I go out and do a campaign, I'm going to have a lot more wisdom than I did the first time. But I found it just fascinating to learn all this stuff. And this area too was something I didn't know a lot about. A good number I had was, so this number 747 are the number of visitors that came to the Kickstarter site and actually played the introductory video I had there. And that's, if I had a less expensive product, you could see where that kind of traffic could actually start to be interesting. I think, probably when people come, there's some price shock and they bounced off the page. Or you can have what's called a bounce if somebody comes to your website and leaves right away because they didn't see something they were interested in. You get those statistics too, and it's called a bounce, and most of the visits to your site are going to be a bounce. But you're interested, once people do stay and do something, you can see what else they did. Now, you don't have that name of that person or anything, but you have, you can see as an individual who visited your site, you can see, did they watch the video? Did they click another link? And so you kind of get summary statistics on that. I think, yeah, so all that stuff was really interesting for me. I think with the, some recommendations on crowdsourced funding, And you can see this, it's really good to go out there and read about this stuff directly. I read some really good articles. You want to build up expectations ahead of time with your own social networking, especially for something where I'm thinking about maybe doing a version of this where I'm making a limited number of prototypes for volunteer work. I think then you can get a lot more discussion with your own social network and maybe get people interested in it. And you kind of want to, depending, I'm not the most integrated person as far as social networking, but some people are, and you can really leverage that. Of course, you don't want to bother people too much and keep bugging them about your Kickstarter campaign. So you don't want to go too far with it. You want to look for other ways to self-promote. I did ping a couple of local places. I didn't have any success with that, but I think, again, thinking a little further ahead of time, like if you could get someone at OPB or some other interviewer interested in an angle on your story, like, you know, what are makers doing during COVID lockdown or something like that? Maybe you can come up with an angle that could be interesting for people to hear about. And then in that way, kind of highlight, you know, your campaign. Definitely look at existing products on crowdfunding sites, Indiegogo and Kickstarter. And there's a couple other ones that I'm less familiar with, but there's more than 2 crowdsourcing sites. Pick a goal that's achievable. We talked about researching your costs carefully. Online ads, are more approachable than I thought. TikTok also had sort of a promise of free initial use, their platform. I never quite met all their requirements, I guess. But Facebook was probably my best experience. And actually, I subsequently read something on Kickstarter that also mentioned Facebook is probably the most promising place to do ads for Kickstarter. And finally, you know, if your first try isn't financially successful, really look at what you're learning from it and maybe try to approach your first one without too high of expectations and really look at it as a learning experience, which was really the way I went into it. And it really didn't disappoint me in that respect. Let's see, any questions on, oh my goodness, time's up. Yeah, so just to wrap it up, yeah, I think as I said, you know, there's a lot of online resources out there. Be patient with yourself. If you get stuck, maybe walk away for a bit and come back to it. Ask help from your friends strategically, don't wear them out. I had a couple of people that I'd ping once in a while when I was really desperate on the programming side of it. As you get more and more specialized, you're going to be more on your own. So again, you know, take your time. You know, I suggest not putting yourself on a clock that has too short of a time if you can avoid it. And, you know, really take that trial and error. Sometimes it feels like you're just beating your head against the wall, but ultimately you learn while you're doing that. So I found just about all of it successful in the aspect of learning from it. And then, yeah, that's it for me.
I do think there are questions.
There's one question in the chat. They ask you about, did you pivot and look for an angel investors like VC or grant or other organization like SPA or SPIR?
That's a good question. I think, you know, over time I could do something like this. I think in the time frame that I wanted to try this out over the summer, I did not do that, but that's definitely another track. And if you've got a good enough business plan, you know, there are VC people out there, even in the Portland area, and depending on what you're doing and sometimes what the social good is around it, it's definitely worth looking into, but I have not yet.
Glen, what I found absolutely fascinating is this compressed learning experience all the way from idea over, yeah. Hey, basically manufacturing, 3D printing, building the system, doing the software, to how would I bring this to market? And I mean, maybe some thoughts on your end. So in the engineering college, we have various programs where we give students a little bit of prototyping funding to be able to do exactly this. And hoping to encourage them to say, well, we live in this world where all of this is at your fingertips. You can make something very real in a reasonable amount of time with a reasonable amount of money. What are your thoughts? I mean, what was your actual time spent on this? What's your background? How much did you know already? How much money did you have to spend to get to that Kickstarter point?
That's a good question. So in my background, you know, a lot of the user experience side of it and smart toys, I had a pretty nice background there around for the concept part of it. Frankly, I need to do more user testing, which is the first thing I should be doing as a UX professional. But I think I've got some limited software background, so I'm not someone who had to start from zero with software, but I'm not a developer. I never have been. And I had not done anything in the maker space. So I'd never used Arduino or anything. So I was ramping up from zero on those. The time frame's a good question because I started doing this like 2 years ago, but it's not like every night I was burning the midnight oil on this. You know, I'd get into spurts where I'd work on this for, you know, a couple weeks and move part of it along. And when you have an open problem, it's kind of something that keeps you going for a space. But then either work got busy or personal life got busy, and you know, I might go for a month or two and not do anything. So it's interesting doing it during COVID. It's a little easier to find the time. My kids are grown up now, so it's easier to find the time. And then the financial part of it, you know, to be honest, I did spend about $500 on online ads, which might sound a little, I don't know, for me personally, it was worth that. I've reached a point in my life where I can afford that. When I was younger, it's not something, when my kids were little, it's not something I would have done. And the maker supplies, like the boards and all that stuff, I've spent a $300, maybe that's underestimating. By the time you include soldering and multiple platforms, and I've gone through 3 or 4 generations of these prototypes, and each time I'd buy a new board, and each time that's $10 plus shipping. Or, you know, these Bluetooth boards I'm using now are more like $30. I've only bought one of those so far, but you can see fairly fast that you're going to be spending a few $100s to operate in the maker space.
But on the other hand, if you had told anybody even 10 years ago that for $1,500 you can have a robotic prototype of something that has animation and moves through the space for under $1,500 in 6 months, starting with not a robotics background, people would have said you're nuts. That's completely impossible.
It is amazing what's out there and what it enables you to do with 3D printing and all these companies offering the entry level of their software for free.
Yeah.
And the Unity Asset Store, I mean, I was able to buy these models that were just really great, I thought. And hopefully they're selling them to a lot of other people because they're beautiful animations and really fun little characters that they made. So it's amazing what's out there and what you can tap into.
Are there any more questions? I don't see any. If not, Glenn, I suggest you should write this up as a story, because really thinking in terms of engineering education, this is how we would want undergraduates to approach engineering.
Good. I hope it's useful, and I've enjoyed talking about it. So it was a pleasure for me to talk about my project. My wife does not want to hear this much about my project. So, yeah.
So thank you very, very much for the last speaker in the last time this term. I think everybody's getting ready for 2020 to be over. Yeah,
let's move on.
Let's move on. 2021, here we come.
It's going to get better than this, definitely.
I really
right.
appreciate your time. Thank you so much.
Thanks, Antonio.
Thanks.
Thanks, Malou.
Thank you.
All right.